Hello everyone, welcome back to my sessions. In this session, we will be learning about malloc method, which is a method that is present in stdlib.h, and this we will be using for dynamic memory allocation, allocating the memory dynamically, that is during the runtime. This is a continuation lecture. If you have not watched the earlier lecture, please do watch and then continue with this. If you want, I will provide the iCard for you. Let us see what is meant by malloc. Okay, so the letter M, so that stands for memory. M for memory, alloc for allocation. Malloc is memory allocation. This method is used to allocate memory dynamically, and using this you can allocate one single large block of memory with the specified size. And whenever you are allocating memory using malloc, it returns always a pointer of type void. What does void mean? Void does not belong to any data type. Whenever you are not sure of the data type or what type of data are you going to use, all the time we use the method void. So you're already aware of the methods void main, very much used. Okay, if the method is not returning anything, we say void. That means empty. It can be used for any purpose. So what we do is, whenever we allocate the memory using malloc, since a void pointer is created to store the data of our requirement, we will typecast it into the type of data that we want to store. Okay, so let's see the syntax shortly. And suppose if it does not initialize the memory at execution time, okay, it initializes each block with some default garbage value. Either, so suppose when you are declaring a variable int a, say suppose you declared one variable int a. So what will be the default value of this? So this will be treated as an auto variable and its default value is some garbage value. In the same way, if you are not initializing this pointer, then by default, it will be initialized with some garbage value. Let's see the syntax of this. So here you can see malloc. To this malloc, we will be passing argument, which is the byte size. What is the size of the memory that is required? Okay, so that size you have to pass. And as I told you, this will return you a void pointer, so that we will be typecasting to the appropriate data type. So based on the type of the data that you are storing, so we will be typecasting it. And since this is a pointer, so pointer should always be assigned to some variable, and this variable type also should be a pointer of similar type. Let's see an example. For example, if I want to allocate a memory space for 100 integer variables, okay, so then you can see the syntax. It is malloc 100 into size of the integer. Here in place of int, if you know what is the size that is taken for the integer in your compiler, you can give the size. My compiler takes 4 bytes. So I can also specify the number 4. 100 into size of 4, or else simply I can give 400 also. Directly I can give the number 400 also, or else I can give it as 100 into 4 also. All these are valid formats. Okay. And this, say suppose here you can see the size of which type of data am I using? Integer. So the cast type. So to which data type I should cast it? I should cast it to integer type. So I should cast it to a pointer of type integer. So I'm using int star, and this should be stored or assigned to an integer pointer only. So here this PTR is assumed as an integer. It is an integer pointer. So to that only you are allocating this. Okay. So I requested for 400 bytes. What happens if that much space is not available? Okay. So here you can see one more example. Suppose, as I told you, we are taking a character array to store the name whose size is 20. Okay. So for this, I want to allocate the memory dynamically. So here you can see the syntax malloc. Directly I'm giving the size as 20 because I know character occupies 1 byte. So 20 into 1 is 20 bytes. So directly I can give a number and I should typecast it to char star and my pointer should be of type character. Okay, so this should be assigned to a character pointer only. So only I'm symbolically indicating it as a CPTR, that is character pointer. Okay, so this allocates, it's not 10 bytes, sorry, 20 bytes. 20 bytes of space for the pointer CPR of type character. Similarly, if you want to allocate memory for a structure variable, okay, at a time, you want to store 10 student details. So for the 10 students, you want to allocate the memory. So here you can see, I have given it as 10 into size of struct student. You know the purpose of size of operator, right? It returns you the size of a variable or variable in terms of bytes. So here, depending upon the student data structure, how much amount of memory is required, that size multiplied by 10. Okay, so that much of space will be created by malloc, and this we are typecasting to the appropriate type. What type of data it is going to hold? It is going to hold a student structured type of data. So I'm creating a pointer or I'm typecasting it to a pointer of type struct student star, and this should be allocated assigned to a pointer of appropriate type. Okay, so for what we have seen, let's recap once. Say suppose I declared an integer array a of 5. So for this, I want to allocate the memory dynamically. Let's see the syntax. It is malloc 5 into size of integer, and this we will be typecasting it to a pointer of type integer, and this should be assigned to an integer pointer only. Okay, so I have assigned to PTR. So in this process, what will happen? You can see one large block of memory of size 20 bytes will be created. Okay, so this much of memory will be allocated and a pointer will be pointing to this. So say suppose if this memory the starting address of this memory location is 10,020. Say suppose it is 1020. So then your PTR will be pointing to the starting location of this. Okay, so from 1020, 20 bytes of memory will be allocated. 1020 plus 20, 1040. So, okay. So those many locations will be reserved for this particular point. Okay. What if I doesn't have these 20 bytes of memory? Okay. So then your pointer will return a null pointer. Always the memory allocation will be failed. Suppose if there is no 20 bytes of memory available. So then since the space is insufficient, allocation will fail and that will be identified with the help of a null pointer. So always you need to check whether the memory is allocated, whether the pointer is returning you a non-null value or a null value. In the next session, we will be talking about calloc. Hope you enjoyed this lecture. If you have any queries, please let me know in the comment section. If you like the video, please do like, share and subscribe.